All right, this is the Geometry Unit 5, Lesson 3 video over medians and altitudes. Um, Before we get into some of the more advanced stuff in this lesson, I want to discuss really quickly what the median and altitude of a triangle are. So the median of a triangle is the line segment connecting a vertex with the midpoint of the opposite side. So if I have a triangle like this, then the median would look like this. It would go, if it was from this point, I would find the midpoint of this other side. Maybe the midpoint is right there, and I would connect those. And that would be what we call the median. Okay, so the median connects the point on a triangle, the vertex on a triangle, to the midpoint of the opposite side. And so that's pretty much it. It just, you know that these two parts of the triangle are equivalent to each other. That information is also on the notes. If you scroll down in the lesson 3, ignore this top part for now. You can see here I've drawn some other examples of what medians look like. The altitude of a triangle is the following. Altitude, line segment from a vertex forming a right angle with the opposite side. So let's look at the same triangle I just got done drawing. Say we have this triangle right here. So what does the median, or what does the altitude look like on this triangle? It's simply the line that goes straight down. It makes a right angle. So you can see earlier, just as an example, our median went over here because that was the midpoint, whereas the altitude goes straight down to make a right angle. Now, there are kind of two unique cases that can come up. Usually it will look like this, but there are times where it will look something like this. Let's say I have a triangle that is already a right angle right there, and I say, hey, draw the altitude of this. Well, if this is the vertex, then the altitude is actually the side of the triangle. It's no different than this side. Or in another instance, what if I have a triangle where I have a side that hangs out, or a vertex that hangs out over the edge? If I have that, and this is the vertex I'm looking at, then I can see that this would be the altitude of the triangle, and I need to sort of, in an imaginary way, extend that side out in order to make that work. You can also see that information down at the bottom of the, what is this, the third page of the notes? Anyways, you'll see it here. So that's kind of some basic terminology that you need to know. And then the rest of this unit is just giving you the other two sort of centers of a triangle. So remember we talked about circumcenter and we talked about end center. So in this lesson, we learn about two others. So when we take the medians, and they're the bottom two, the medians of a triangle, and we intersect them together. Oops, sorry about that. When we take the medians of a triangle, we intersect them together. This point here is what we call the centroid, and that's yet another one of our four centers. And then secondly, when I take the altitudes of a triangle and I find their center, or their intersection point, that is called the orthocenter. So really from here, this becomes pretty vocabulary heavy. I'm going to scroll down here to show you what I mean. Basically, numbers 1 through, lots of vocab. 1 through 12 is going to come from the lesson vocabulary. So you need to read over the lesson, and that vocabulary, a lot of it I just talked about, but there's more information about these things that you'll need to read in the lesson itself. So a lot of vocabulary, and then you get to 13 through the end, And these are a bunch of these diagrams. There's the same 4 diagrams for each one of these 8 questions. So I'm going to tell you right now, you need to do some identifying. And I would say that this page of the notes is going to be hugely helpful here, because you can see here that I've gone ahead and told you, okay, the perpendicular bisector gives you a circumcenter, and this is what a circumcenter looks like. What do I look for? Well, I look for right angles, and I look for bisecting. What about angle bisectors? Well, I look for angle bisectors intersecting to make the incenter. So what you're going to do is, like in this first problem, it says, which triangle involves perpendicular bisectors? Okay, so I need to look for lines that are perpendicular and that are bisecting. So like, just as a real quick example, what I mean, this shows bisectors, but they aren't perpendicular. So then that's not the answer for that one. This one shows perpendicular again, but no bisectors. That's not the right answer. This one shows a right angle, perpendicular, but no bisecting. So that's not the answer. So it has to be D. So I've gone ahead and told you right there, the answer is D here. So then D also refers to which of our 4 centers. Well, if I go back to my notes, I'll see that perpendicular bisectors correspond with the circumcenter. So then what I would do is I would go down and back in my lesson, and I'd look for the question that asks about circumcenter. So I go down and I say, okay, angle bisectors, medians, altitudes, centroid, circumcenter. That's answer choice D. So that is what you need to be doing on this part of the lesson. So utilize this diagram and what it tells you to help answer the material on the lesson. I think that should be enough. It's more or less just like matching up the images so that they kind of correspond with the which diagram it's referring to here on the lesson. And that is it for lesson 3.